battery. Okay.
So it looks like when you're transferring over power when the car battery dies.
Okay, so you want me to jump start something?
Yeah.
Okay. Okay, so tell me about these.
Those are cables.
Cables? You mean like that hold up a telephone pole or something?
Like power cables.
Power cables. Okay, what's power? It's the ability to record it. Yeah. Let's see. What happened to this stuff? Okay. Any idea what that stuff is? That's a good idea. Why in the world would I be pouring sodium sulfate into this? And let's see. Let's see. Okay, so what am I connecting down here? Anything? Is this hair sticking out the bottom? Or metal? Okay. So some kind of metal device that's sticking up onto a paddle, so it's connected electrically to something in the bottom here and in the bottom here. And so what's this filled with?
Sodium sulfate.
Sodium sulfate, okay, which is what kind of a compound? Ionic, molecular, came out of the sky, who knows? Ionic, because we have sodium always forms only ionic compounds. So we have a metal, and then this is a polyatomic nonmetal. So this is 0.1 molar, which is actually very weak. There's not much of it in there as far as concentration goes. And I put a little stopper out, and I'm leaving that open anyway. So hopefully nothing will pop out here. These are called stopcocks. Or I don't know if that's an obvious reason or not. Let me go over here and steal something. Brought some additional things too. Additional toys. And this one I'm going to use for not the purpose it was designed. This is called cleaning it off. Okay. So these stopcocks, if I turn them vertically, you can see that. If I rotate them so that they'll be able to release whatever is inside here. And if it happens to be, say, something like gas, well, if I turn them now, because of the weight of this, it would push this up, something like a siphon. But what I'm going to do is I'm going to be collecting gas up in the top of here. Gas is less dense than whatever happens to be in here. So it's going to go up from these electrodes, and the gas will wind up over here if everything works. So let's see, these stopcocks are closed. I will be able to release the gas later into whatever those things are, which I hold up. What are those called? Test tubes, okay? So these are called test tube holders. So we'll be able to hold the test tubes and collect the gas, and then find out what's going on. This is a power supply, and I'm able to put a strong negative charge on one and a strong positive charge on the other. What's coming out of the negatively charged one? Something comes out of it. I'm always asking you guys.
Electrons.
Electrons. Wow, that's a good guess. Good guess. Okay, so what's this thing called back here, by the way?
Heat sink.
A heat sink. Okay, so you have something that requires a heat sink. It takes the heat and it splits it out, disperses it out. Okay, this is the power switch. It may be. Oh, good. It works this time. So let's see. What's this? Of course. Let's see. What am I looking for? Turning up the. This is the voltage, which is the amount of push that the electrons are getting to go from one place to another. In this case, from the black one over here to the red one. And that's good. Usually we don't get that much voltage, somewhere it's usually around 15. Today it's about 19 volts, which is good. This tells you how quickly the electrons are going. You can't see it from here, but just realize that something is happening. And what is it?
It's bubbling.
It's bubbling, okay, bubbling, fizzing. And so what would that indicate?
A reaction?
A reaction, exactly. It's called gas evolution, as an indication of some kind of a chemical reaction, particularly when there's no additional heat involved. That is, we're not applying heat, so the stuff is not boiling. Also, these are very, very fine bubbles. So if electrons are going through here, does that have anything to do with the bubbles? I'll give you a hint, yes. Okay, so this is, if this is supplying electrons, then something is over here that will eat those electrons, eats them very happily. And something over here that doesn't mind taking the electrons away because it has the positive charge. At least I assume. Sometimes this has been reversed according to the way this is put in. But actually we'll be able to tell which is which after we see it collecting the gas up here. So this is rising up. And why would the bubbles be really fine? Do you have any idea of that? Why aren't they big blobby bubbles?
It's a slow reaction.
Well, sort of, but I can have a slow reaction where I gradually inflate the bubble and then it goes up like that. But in this case, it's a question I never asked before, but what it is the water, or the solution, is in close contact with here. That's able to pick up individual electrons. And so it isn't until there's enough volume in each of these that they're actually able to rise up off of that electrode. The electrode being the thing that is collecting the charge. Now, what do we know about circuits? An electrical circuit. One thing is that it has to be a circuit. One thing that if you have a power supply, there has to be some connection through the whole thing. You can actually break a circuit, and then the electrons won't flow through there. So what I have here is this is an electron pusher. That's what a power supply is. So it's pushing electrons out this way, and it's sucking electrons this way. So what we have to have, in order to make this a circuit, there actually has to be a way for the electrons to get from here over to here. Now, all these electrons are being pulled off from here, and they're being sucked out from what's on this side. So we still have to have something that is taking the charge and making it go from one side to the other. So what we have here with this is this sodium sulfate stuff. And this being aqueous, divides out into the sodium and two of those so that we can counterbalance the charge, and the sulfate anion to negative. And both of these are aqueous. Well, does anything